In this video, we will look at how the area of a circle is actually pi r square. We were taught in classes 8, 9 and 10 that the area of a circle is pi times r square, where r is the radius. And pi by definition is the ratio of the circumference to the diameter of a circle. The area of a triangle is used to find the area of any polygon. Whether it's a pentagon, a hexagon, a septagon, we can divide it into several triangles. And we all know that the area of a triangle is given by half base into height. The same concept that the area of a triangle is half times base into height can actually be used to find that the area of a circle is pi times r square. Now let's see how this happens. Supposing we have a square. All four sides of the square have equal sides and the dimensions are a units. Supposing I split the square into two triangles, triangle 1 and triangle 2. Now by geometrical definitions, both the triangles are equal and they're also congruent. So what happens over here is that the area of a square is a square and the area of the triangle is nothing but half of a square. Now, if we split up the two dimensions of the triangle, which are a and a units, what we get is the area of a triangle is nothing but half into base into height. Let's move forward and find out why the circle is actually a triangle. Supposing we have a circle and the two radii, and at the bottom we join the tips of the radii where the radii actually meet the circumference of the circle. So we get a triangle, and this is an isosceles triangle because two sides are the same. They are the radii of the triangle. Of the circle. Moving forward, supposing I were to collapse the two sides, bring them closer, I still get a triangle, an isosceles triangle. But there is a little area which is left below the base of the triangle, which is actually you may kind of call it the sector of the circle. Supposing I were to proceed further and eventually collapse both the radii so that both the radii they actually superimpose. What happens in this case is first that the radii superimpose. Secondly, I have created an isosceles triangle because both the sides are equal to radius r. The base is now actually a very infinitesimally small tip on the circumference of this particular circle. And n such isosceles triangles are created because by definition, a circle is nothing but a polygon of n sides. Moving forward, we take this particular case whereby we have the radii of the circle superimposed and the base of the such called triangle which is created is actually a small tip on the circumference of the circle. The first thing is that the area of each triangle by the definition of the triangle mentioned in slide number 1 is equal to half multiplied by base, which is actually a small tip on the circumference, multiplied by height, and in this case height is the radius of the circle. The second point is that I create n such triangles if I were to move in a counterclockwise or a clockwise fashion. So area of n such triangles would be half times n multiplied by base, which is the small tip, multiplied by the height, which in this case is the radius of the circle. Why I have written n along with the bases, we'll shortly see that. Area of n such triangles is nothing but half multiplied by circumference, and the circumference in this case is nothing but the n small tips added together, multiplied by the radius of the triangle. Area of n triangles then reduces to half into 2 times pi into radius. By definition, the circumference of a circle is nothing but 2 times pi times radius. Let's look at the area of the circle now. Half and 2 get cancelled off and we are left with pi times radius into radius, which gives us the area of the entire circle as pi r square. My name is Vishal Bhatia. I did a master's in accounting and finance from the London School of Economics. I can be reached on WhatsApp on +91, which is the country code for India, followed by my WhatsApp number 98710 59470. Thank you very much.